Good afternoon. I'm very pleased you could all attend this session dedicated to engineering to order and key trends in the industrial equipment industry. We'd like to share with you our understanding of the ETO process, what its key characteristics are, and the required solution to execute this process. In the next 25 minutes, we'll illustrate how Dassault Systèmes takes in account this specific process and introduce our solution that we believe answers the needs of industrial equipment companies. Several years ago, Dassault Systèmes changed its approach to the market. What drives us is the industry. Our strategy and solution roadmap is defined based on specific industry requirements and trends. Our technology serves the specific customer process as we understand it today. It can change based on emerging IT capabilities. We cover 12 industries. Industry organizations are in charge of defining 3DS strategy and building the solution roadmap. The organization is also responsible for supporting key customers. Industrial equipment is one of the key industries for Dassault Systèmes. Let's see what type of companies belong to this industry. Industrial equipment is the combination of 6 different segments, which are illustrated in this chart. It spans from the individual part and component, where we have a large number of customers, to very complex products like complex excavators or big paper machines with hundreds or thousands of parts. These very complex products are highly customized in response to specific customer demands, but also to local regulations and local equipment providers. An additional layer of complexity arises from the fact that these products include more and more sophisticated electronics, sensors, and embedded control software. These essential technologies drive product innovation. In addition, companies have become global organizations, serving customers all over the world with diverse demands that require complex networks of suppliers and local manufacturing resources. These companies operate in a new environment. It's a major evolution in this industry. Let's speak about an extremely important trend. Ladies and gentlemen, the 4th industrial revolution has started. You may be asking yourself, okay, but what is it? What were the first 3 revolutions about? Well, in the end of the 19th century, industrial production began, but was primarily manual, with few machines. The mid-20th century was characterized by a new production organization driven by the need for more efficiency. This new production line was well illustrated in the automotive sector. At the end of the 20th century, we saw the emergence of full process automation, executed by intelligent machines and piloted by digital product definition and manufacturing automation. And what about the 4th industrial revolution? Today, our way of life presents significant challenges. We collaborate with people we don't even know. TV, smartphones, and maybe our watches are connected to the internet. We don't want standard products. Even our cars are customized to our tastes. And because we're always on the move, we need more and more services and support to make our lives easier. With this evolution in society, manufacturing plays a key role. It's not only a consumer problem, it also has a major impact on the production system. Companies are adopting these trends and changing the way products are made. They are proposing products people are looking for. Let me speak a little bit about each aspect of this revolution and how it impacts your business. Firstly, collaboration leads to social production, bringing all stakeholders together and creating machines or machine parts in a sustainable way. The way we collaborate is changing. Sending multiple emails is cumbersome. Many companies apply new social collaboration in their organisations to streamline the exchange of ideas, to promote working in groups, and making the decision process a smooth one. Secondly, the Internet of Things leads to smart production, to connect products, machines, plants and people. A GE plant manager has been able to relaunch his factory with his iPad from home after he received a warning that a storm had stopped production. You need intelligent devices to build intelligent products. Thirdly, customization leads to flexible production to create products that the final consumer is looking for. Flexibility is not only manufacturing many different products easily, but also reducing cycle time from idea to product in order to adapt to market trends and social evolutions. Fourthly, servitization leads to service production to provide the best consumer experience for your customer. Maintenance mobile applications for construction and agricultural vehicles are proof that people are not only looking for products, but for complete experiences. Companies have to face many challenges, and the importance of those challenges varies from one segment to another. All of them drive the search for solutions to increase performance. There are 6 key challenges common to all the segments in the industrial equipment industry: collaboration, diversification, fast development and delivery, the ability to leverage smart components and to optimize global or local production, and finally, the transition to service business model. The 4th industrial equipment revolution clearly impacts how companies must revolutionize their processes. The first impact is on the product architecture itself, as this drives how ETO processes will be efficient. New product architecture allows companies to reduce the amount of engineering needed to answer specific customer RFPs. Of course, working on the product architecture is a huge investment, but it is key to long-term profitability. A very well-known example is Scania in the truck and heavy industry, or VW in the automotive industry. This new product architecture also influences the production system. The automotive industry has clearly become more agile, and we're seeing this trend gaining ground in other IE segments. We've seen at some of our customers that the need for a flexible production system is driving the characteristics of the PLM system. Engineering to order is today's answer to provide the end customer with customized equipment. In a long-term vision, the ultimate goal is in fact to reduce as much as possible the demands on engineering and to create specific configurations by combining predefined modules. This configured-to-order methodology, as shown in this illustration, is the foundation on which companies can base the analysis of their full product cycle. This means modules are defined not only based on engineering needs, but can be driven by maintainability requirements or cost efficiencies. This can be considered as the methodology of the future in answer to highly variable demands. ETO is in fact a process. It combines internal and customer-related processes. It begins with the internal process of innovation, piloted by customer demands and a long-term vision. This enables companies to create the product baseline, which will later help to build up the proposal. In fact, a lot of ETO efficiency is probably already established in this phase. A good product architecture will dramatically facilitate the design of a specific customer configuration. As soon as the inquiry is received, the process can begin. Depending on the segment, this is typically a 6 to 18-month process for large press machines, for example. What is important is the TTA, time to acceptance. Yet once a product is delivered to a customer, there is still a period of time during which the client will test the product to check if it matches expectations. What are the key challenges to execute this ETO process? Being fast and keeping control. There's no value in being fast if the quote or delivery is not what the customer expected. Balancing these two parameters is always a challenge. Being efficient depends on capitalizing on practices that have been successful in the past. In fact, in a global environment in which design is distributed and manufacturing is split in many locations, allowing reuse of best practices and knowledge capitalization are key success factors. And the last challenge is about the IT infrastructure supporting this ETO process. An ETO process combines many disciplines. Engineering, of course, but also sales, purchasing, installation and service, which traditionally use dedicated solutions. These solutions should work in a collaborative mode, but most of the time this is not the case. The key characteristics of ETO processes are multidiscipline. In the engineering world, with mechanical, electrical, SW, but also including sales, finance, contracts and the supply chain. The equipment that is sold is most of the time maintained by the company itself. Including serviceability in the design and the proposal is essential. Going from design to cost to design for service. A second characteristic is traceability. Essential to executing the IT is, of course, the internal processes that monitor the IT, but also the customer relationship. This change leads to differences in the final product. It impacts the contract and payment. And finally, they need to ensure that all changes do not affect the equipment's compliance with regulations. What are the key indicators used to measure a company's efficiency? Obviously, the first one is the success rate. The number of wins compared to the number of RFQs answered is a good measurement. Above 30% is considered a good ratio. But winning many projects is not enough if the project is not profitable. Profitability must be analysed, of course, for the project itself, up to acceptance, but also in the company's capacity to generate added value services like maintenance or spare parts. Finally, as already mentioned, managing knowledge to create efficiency. Something not understood is the ROI of knowledge capitalization. In fact, the more a company will reuse existing elements, the greater chances it has to lower risks of failures and increase margins. The best way to measure capitalization is probably to count the number of elements that are reused in a new project. Here are some examples. Jakob Müller designs and manufactures textile machines, essentially focusing on delivering customized machines. The benefit of a control ETO process is the ability to quickly deliver high-quality machines, but also, as expressed by Jakob Müller himself, the ability to control their process. Remember the need to be fast and in control. Being able to trace the activity of every actor is essential. It helps to precisely meet customer requirements. No more, no less. Another example is Mead Westvaco. Here is a company that designs and manufactures machines for secondary packaging in the beverage, food and healthcare sectors, and for a variety of other consumer products. As you can see in the quote from the manufacturing VP, the target is not to divide lead time by 5% or 10%, but by 1/3. Why? because the package definition is totally connected to trends in consumer behaviour. Once this behaviour is understood, companies must react very quickly to design products that respond to those trends. Time to delivery is key and a huge competitive advantage. Now that we've explained what ETO consists of and what the KPIs are to measure its efficiency, we'll now explain the 4 main objectives and what we consider as the 4 solutions to improve processes to establish an efficient ETO approach. To manage the product architecture, we see 3 main components, which are A. The efficiency of the bill of materials process, B. Having a system approach, and C. Finally having the ability to integrate different disciplines on a same platform. Thanks to this multidisciplinary approach, you can now seamlessly connect design, simulation and manufacturing, which is critical to implementing your ETO process. As we previously explained, ETO is a process, and one of its advantages is the ability to capitalise on existing elements. As a result, this process is managed thanks to project management tools that are integrated in the ERP and potentially the CRM of your company. As IE projects are usually complex, companies often subcontract work to suppliers to install a machine or to produce machine components to save time and money. As you can see, we're in a multidisciplinary environment that involves several sites, several expertises, and also external stakeholders, such as suppliers and even customers. To manage this, we need to have a unique platform which will enable everyone to interact and work together throughout the entire project, enabling each to access the enterprise data and to build and consult dashboards to monitor and help with decision-making. To conclude this presentation, here are a few takeaways. The 4th Industrial Revolution drives companies to adopt new methods to address mass customization and production agility. To efficiently execute engineering-to-order processes, you need a single version of the truth. This requires having a business platform as a unique data source for all your company stakeholders. Finally, the next challenge for industrial equipment companies, as it's been the case in the automotive industry in the past, will be to strategically move from an ETO to a configure-to-order process. Thank you for attending this webinar. Don't hesitate to ask us any question on our social media accounts, and see you soon on our website.